Hello, my name is Kevin Tsui, and I'm a fourth-year graduate student at UC Berkeley. Currently, we're at the Hockemeyer lab, a neighboring lab of the one that I work in, which is the Robert Tejan lab. I grew up in Taiwan for the first part of my childhood, and then I moved to the Bay Area, actually, which is where we are, when I was approximately 8 or 9. I was always scientifically inclined. That is not to say I always liked biology. I like to understand how things worked, so I think you can say that's more scientifically inclined. Like I said, I really like mechanical things actually when I was younger, because things just make sense. You know, when you have a cog, you turn one thing, you can see the rest of the machine work, and you can see individual parts of how they work. So I always really liked physics and mechanics, but as I got into biology in high school, it was kind of amazing when I could see in textbooks all these things that were described to me that I had never even thought about before. You know, all these little things inside of your body and how they come about. That's not something you can observe by yourself. And you know, reading and understanding how these things just kind of fit together logically, it was quite amazing to me. And that's really the first step of me really favoring biology over something like chemistry or mathematics or engineering. So my lab is actually more interested in what you would call basic science, meaning that our studies are not primarily focused on an individual disease. For example, some labs revolve around cancer, and they study various aspects of cancer. For us, we're more interested in a process called differentiation and transcription in that regard. And what that means is, you know, you have different cells in your body, and for example, you have a muscle cell, you have your skin, and then you have your heart, and your fat, and your hair, and they're all very, very different cells. But they all came from originally one single cell. How does this happen? How do all of these cells become different things? And you can imagine that there are what you can just refer to as like managers. Each cell takes on a particular manager that specializes in becoming, let's say, a skin cell, or a heart, or fat. And that's what causes that cell to become certain things. And what our lab does, or studies primarily, is how do those managers work, and they're called transcription factors. If the manager screws up, it's a fairly big effect. And in fact, there are multiple neurological diseases or craniofacial diseases that come from essentially transcription factors misfiring or not working as well. P53 is a transcription factor that's misregulated in cancer, and it's actually, if I remember correctly, it's one of the first transcription factors related to cancer that was discovered. So it's along those veins, although we don't work in any particular disease. Being a scientist is not for, I would say, the faint of heart to be dramatic, because you have to realize that failure doesn't mean that you screwed up. Well, it could, but you know, if it doesn't work, it doesn't mean it has to be something that you did wrong. And it doesn't mean you can't learn anything out of it. You take the result and you try to learn what you can, and you try to design your next experiment and improve upon that. Any time that I get a positive result during the day is a huge high, and that's really, I think, what scientists live for. It's that one time, well, out of, you know, a couple of weeks or maybe a couple of days, where something works and you just feel like you're on top of the world and you can do anything. Science is certainly something I feel like everyone can do if they want to do it. Take me personally, I'm the first in my family to graduate college. I'm the first in my family to go into science, and my parents obviously have no scientific background, but science is a very, I think, individual thing where if you're interested, you can do it. And you know, if you read enough and learn enough, you know, I don't think intelligence or like innate ability comes into play, because when it comes to science, it really is about 99% hard work. You can't be a genius and not do any work and succeed in science. As long as you're willing to work and willing to learn, willing to fail and learn from your failures, I believe anyone can really achieve a career in science.